Now we will move forward to discuss the fundamental theorem of divergence. Now, in order to just see the analogy, let us just rewrite the fundamental theorem of calculus first. That the derivative of function df by dx when integrated from some lower limit to upper limit is equal to difference between the values of the function at the boundaries. Now this derivative is going to be, we are going to replace this derivative by the divergence type of derivative. So accordingly, the integration gets modified and this theorem reads as integral del dot v bar. So this is the divergence part replacing the ordinary derivative. When integrated over a volume v is equal to the closed surface integral of v bar dot dA bar. Now this type of form we have already sometimes seen in electrostatics. It is the well-known Gauss theorem. So alternatively, this theorem is sometimes also called as Gauss theorem. Or in mathematics, this theorem is usually known by the name Green's theorem. So these are just the alternate names of the fundamental theorem of divergence. In order to check this, we can have an example where the vector function v bar mentioned in the theorem is given as y squared x cap plus 2xy plus z squared y cap plus 2yz z cap. So we can readily check the left hand side. Now if this is to be integrated over a volume as per the left hand side. So let us consider this volume as the volume of a unit cube. Now a unit cube is a cube of sides of length 1 as shown here. So these are the limits over x running from 0 to 1, y running from 0 to 1 and z running from 0 to 1. On the left hand side, as we can see, is just the del dot v bar integrated over d tau. So for this type of structure or volume, the element d tau in Cartesian coordinates can be written as dx, dy, dz, and the limits on x, y and z all are 0 to 1. Now for this function v bar, its divergence del dot v bar, we should know that del is x cap, just a minute, dou by dou x plus y cap dou by dou y plus z cap dou by dou z. So accordingly, for these three terms, we are going to take the derivatives with respect to x, y and z partially. So the first term goes to 0 as derivative of y squared with respect to x is 0, plus the second term comes out to be just 2x, y derivative of y is 1, z square goes to 0, plus then the next term z gives us 2y. So del dot v bar is just 2 times x plus y. Now this has to be integrated over the volume. So we should write it as a triple integral x plus y 2 times dx, dy, dz, all of them running from 0 to 1. This can be easily solved by applying the techniques of integration, and we see that this is just equal to let us just try to solve this. So let us first integrate this. Now this factor 2 can be taken outside the integration since it's a constant. So integral x plus y dx would give us half of half plus y. Now this x integration is done. So integral half of y, half plus y dy. This would give us just 1. Of course, the limits are from 0 to 1. So the second integral is done. And now the integral of 1 with respect to dz from 0 to 1 will be just equal to 1. So the left hand side comes out to be equal to 1. So the right hand side of this is integral v bar dot dA bar closed over this volume of the cube. So this is effectively the flux flowing through the cube. Now this can be done by taking 6 of these faces one by one, and we can calculate the integral of v bar dot dA bar for each of the 6 faces, where this dA is just n cap dx dy, then n minus n cap dx dy accordingly, then n cap dy dz minus n cap dy dz and n cap dx dz and minus n cap dx dz. This we have already seen in previous lectures. So there would be 6 different surface elements corresponding to the 6 faces of the cube, and each will have a value of integral v bar dot dA bar. This can be done, which is a tedious job. So we will get 6 values of integrals, namely 1 by 3, minus 1 by 3, 4 by 3, minus 1 by 3, 1, 0. So if we add up all these values, this is just equal to 2. Yes. Now we see that this integral was equal to 1 and we had a factor of 2 already taken outside the integral. So in all, the left hand side was equal to 2, whereas the right hand side has also been found out equal to 2. So for this particular v bar function, we have verified the fundamental theorem of divergence, or Gauss theorem, or Green's theorem as they call it in mathematics. Thank you.